Hi and Assalamualaikum. We are from Group 4. We present milling process. This is our group members, AMMAR HAZIQ, NURUL Iman, SHAHMI NASRADI, SUHANT, and lastly KISHEN. In this video, we will present what is milling, operation of milling machine, tools and equipment, process plan, methodology, results, precautions and safety rules, and lastly discussion and conclusion.
Hello, I'm Kishen Ramachendran. My metric number is M823064. So today I'm going to talk about what is the milling. Milling is a machining process that used to rotary cutter to remove the material by advancing a cutter workpiece. It's known as milling has been an ability to produce a variety of a shape and has a high product. While a work part is a feedback rotary cycling tool that has a multiple cutting edges, as known as a milling cutter. Operation on milling machine. Facing is to reduce the length of the workpiece. A second, a slot milling is to cut the slot. As a third, drilling to make a hole. As far as counter boring to make a hole little larger. Now we're going to talk about the tools that using in the milling. First, we need a vernier caliper to measure the length, width, and the depth of the workpiece. And second is a vernier height gauge to measure and make a height of a workpiece so that we can calculate or we can put the marking on the workpiece. So third is the end milling cutter to cut a shape of a material. Fourth is a counter bore drill bite to make a hole with a flat bottom and a larger diameter on the top. So the sixth is a drill bite to generate the whole workpiece, and the sixth is a center drill bite to make a tiny hole, a starting point to the bigger hole, so that it's a center drill is used to put a bar, so that it's a marking to make a hole bigger. And now there's a C-type wrench spanner to loose, secure, and adjust the chain so that it can be conduct uh, tighter. Drill chuck to secure the drill bite. Uh, Collect chuck to hold a center cutting tool during the machinery operation. Now I'm going to talk about equipments. Well, vertical milling machine, a type of a machine which removes the material from the workpiece to achieve the design shape by feeding the work pass and the rotary cutter. So that machine is using to make sure cut the workpiece in which type of a shape as we wanted.
Okay, hi and Assalamualaikum. My name is NASRADI bin SHAHARUDIN. My matrix number is MA23105. So today I'm going to present about our process plan. So the first one is measure the workpiece by using vernier caliper. Next, we do facing by using face milling cutter. The next step is step milling by using two fluid end mill 16 mm diameter, and next one is slot milling, two fluid end mill 8 mm diameter. And the second last one, we center drill and drilling by using center drill bit 8 mm and 9 mm diameter. And the last one is counter boring, counter bore M8 or 15 mm diameter.
Hi, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ammar HAZIQ bin Muhammad Nasir, and my metric number MA23098. Today I'm going to explain to you the methodology. So in simple things, methodology is like set guidelines that helps people do things in an organized and effectively. So first of all, let's start with machines at top. The machine switch button was turned on, the lamp was turned on to ensure that the process could be observed. A suitable fluid amine was inserted into the black chuck at half of each body to ensure stable rotation. The end mill cutting tool is then slotted into the spindle and righted with a handle. The speed of the machine was adjusted to 750 RPM. The direction of rotation of the spindle was observed before the milling process began. Okay, then let's move to the measurement. The dimensions of the workpiece were measured using a vernier caliper and vernier height gauge. These measurements were used to determine the depth of cut and the feed rate. All right, now let's move to the facing phase. The workpiece was attached to the milling machine table using clamps to prevent it from slipping. The face milling cutter was mounted on the spindle of the machine. The workpiece was placed perpendicular to the axis of the cutter to ensure that the cutting process works in the right position. The feed rate and spindle speed were adjusted to 750 RPM to prevent the workpiece from breaking. The machining process began with the cutting tool rotating at a clockwise rotation. After the facing process was completed, the dimensions of the workpiece were measured again using a vernier caliper. Then for the step milling, the workpiece was attached to the milling machine table using clamps to prevent it from slipping. The two-flute end mill, 16 millimeter diameter, was mounted on the spindle of the machine. The workpiece was placed perpendicular to the axis of the cutter to ensure that the cutting process worked in the right position. The same feed rate and spindle speed were used. The machining process began with the cutting tool rotating at a clockwise rotation. The workpiece was fed into the cutting tool at a specific depth of 4 millimeter. After the step milling process was completed, the dimensions of the workpiece were measured again using a vernier caliper.
Hello, I'm Iman binti Muhammad FOUZI, matrix number MA23112. Next, slot milling. The workpiece was attached to the milling machine table using clamps to prevent it from slipping. Two fluid and mill and diameter was mounted on the spindle of the machine. The cutter was adjusted to the starting point of the slot and the cutter was turning clockwise and passes through the end of the slot and the same feed rate and spindle speed were used. Next is center drilling. The workpiece was attached to the milling machine table using clamps to prevent it from slipping. The center of two holes was marked on the workpiece. A center drill bit was mounted on the spindle of the machine. Center drill bit was used to create a small dent in the surface of the workpiece as a starting point for the large hole. Lastly, drilling and counter boring. After the center drilling process was complete, the two holes were drilled using drill bit 8 mm and 9 mm diameters. Counterbore M8 was used to enlarge the top of 9 mm hole. When counterboring operation occur, we lower the speed of the machine to 430 RPM.
Okay, now this is the results of our workpiece. So the left one here is the front view of our workpiece. This is the top view and this is the side view. So this is the result, the isometric of the workpiece. This the right the right picture here is the picture that I've drawn by myself, and this orthographic projection of the workpiece is drawn by me also. So as you can see here at the bottom left is the top view. At the top left is the front view, and then the right side here is the side view.
Hey, my name is Raj and my metric number is MA23103. So I'm going to continue with precautions and safety rules. Number one, the workpiece must be clamped and secured in a vise and vise clamped tightly. Number two, make sure the cutter is rotating in the proper direction before cutting material. Number three, make sure that the machine is fully stopped before taking any measurements to avoid any accidents. Number four, use the shield while the cutting process occurs to prevent chips from hitting other people. It's the discussion. Number one, the milling process focused on face milling of a metal block using a two-flute end mill with 16 millimeter diameter. Number two, working in a controlled lab environment ensured the safety for our team. We adhered to strict safety protocols and ethical guidelines, minimizing risks associated with the handling machinery. Number three, the metal block was first faced with spindle speed at 750 RPM. The metal was cut in a clockwise direction with two flute end mill, 16 millimeter diameter, mounted on the spindle. The metal is then cut to a specific depth of 4 millimeter. Number four, in slot milling, two flute end mill, 8 millimeter diameter was mounted on the spindle. Then two holes were drilled with diameter 8 millimeter and 9 millimeter. The counterbore M8 cutter enlarged the hole of the top of the 9 millimeter drill hole, and the machine speed was adjusted to 430 RPM. Finally, the conclusion, this milling experiment provides a successful demonstration of practical milling techniques. Then, realization of parameter settings impact on the final product, and enhance efficiency through task division and regular communication. And finally, strengthen technical skills and teamwork in a technical environment.